Hi there, today I'm going to be restoring this Heathkit SB-610 ham radio station monitor. So what this is kind of like an oscilloscope. You see the oscilloscope screen there, as well as a bunch of dials. But in the back it's got some UHF antenna connectors. And what you would use this thing for is you would hook it up to your ham radio and you would monitor your output to make sure your output isn't like over leveling and getting cut off, or that you have other modulation problems. I think you can also use it to measure some inputs and maybe even use it as a general purpose oscilloscope in some scenarios by setting some of the options on it. Now you probably say this thing looks pretty good, but I have already repainted the case. So it was painted in the original Heathkit green color. And the paint, it was coming off in the packing material, it was coming off in the box, it was coming off all over my workbench. Wasn't really sure how toxic that stuff was. You know, it could have lead in it or something, so I took it and I stripped all of the paint off and I painted it black with like a satin black to match my Drake equipment. Now I know some Heathkit people would of course paint it back in the original Heathkit color. Some Collins people would paint it in kind of the Collins cream color. It matches the Collins gear well. Me, I painted it black because it'll go along with my Drake equipment. So it looks nice, and while we're looking at this over, I wanted to go over the definition of what a used item is on eBay. So this was used, and used is an item that has been used previously, certainly was. An item may have some signs of cosmetic wear, green paint all over the place, sure, but it is fully operational and functions as intended. So fully operational. This item may be a floor model or a store return that has been used. See the seller's listing for full details and description of any imperfections. So for a seller to classify something as used, it does have to be functional. That's why you see a lot of stuff that is marked as non-working for parts or repair, because people don't want to have to deal with the return. In my case, I wanted to recap it anyways. I'm really not concerned if the thing did not work out of the box, and I kind of do not expect stuff I buy on eBay to often live up to the description, and more often than not, something you buy on eBay does not work right. So anyway, let's take this thing apart and take a look at it. And here we are. This is the bottom of it. Flipping it over. Here is the top. So it's got, what, 1, 2, 3, 4 tubes in it, a capacitor, a transformer, you know, more discrete capacitors around the oscilloscope tube, and a whole bunch of capacitors and stuff on the bottom. These tubes are pretty grimy and kind of old. But so what happened is, when I turned this thing on, I hooked it up to my, my Variac so I could power it up slowly. I powered it up, of course nothing happened. Didn't turn on. I found this fuse here. I think this fuse was blown. But when I went to pull the fuse out, it completely crumbled apart. So I think that fuse had simply given up over time. So replaced the fuse, put it back in the Variac, cranked it up, and it actually lit up. I got a green dot on the screen. It wouldn't sweep. So there's something wrong, and it wasn't sweeping. The dot was a little bit out of focus, so I adjusted the focus control, the dot came into focus, and then I started hearing some static from the speaker, which is kind of surprising because this has no speaker. And then the static turned into the sound of frying bacon, and then I powered it down. And what had happened is, I don't know if you can see it here on this one a little, yeah, right there. This capacitor here, this high voltage capacitor, is leaking some kind of electrolyte or something. And it had heated that up, liquefied it, it had dripped out all over the desk. So this capacitor here is almost certainly bad. There you can see kind of there's still some liquid in there. So that one's shot. Its neighbor, I wouldn't be surprised if it's shot as well. Looking around in here, I don't know if they're obvious. I'll have to look. It could be these, but I've looked at the schematic and there are some diodes associated with this. So we've got some capacitors, some diodes. I think it may be a voltage multiplier, but it went bad. Those things are rated at 1200 volts DC. We definitely need to replace those caps. There's more caps in here. This is a big guy here. There's a couple back here. These are slightly lower voltage, 350 volt, but they're pretty old. So another old electrolytic there. Of course, there is the big can capacitor, this one here. And then there's this wax covered thing up front. It's possible that this grubby looking wax thing here could be that could be why we weren't sweeping. Maybe it's associated with the sweep circuit. Replace it and find out. But anyway, certainly was used, but it was not actually functional. It had a blown fuse and multiple capacitors that need replacing. So I'm going to go ahead, and in this video I will recap this thing, I will restore it, I will get it working again. Now usually when I go to recap something, I'll just order the capacitors from Mouser. This time I decided to buy a kit from Hayseed Hamfest. And the reason I did that is because they have a replacement can capacitor. It's not an original can capacitor, it's one that they built themselves. But I added up the price that I'd have paid Mouser versus the price that I'd have paid for the Hayseed Hamfest rebuild kit. And the price difference really wasn't that much, and I get the can capacitor and it would look original, so I figured why not, I'll do that. I'd never done a Hayseed Hamfest kit before, but I figured we'll try it out. So opening it up here, we've got some goodies. For like an extra few dollars, I got a set of resistors that are supposed to go with it. Nothing super special about these. It does have a little chart here saying where they go, the quantities, where they go. They're the right wattage. Like I say, I could have bought those from Mouser. We've got a set of discrete capacitors here. Nice, modern, newer ones. Low voltage ones as well as some high voltage ones. Modern caps are all smaller than the old vintage ones, so these are all smaller than what you saw on the radio. They look a little bit tiny in comparison. You know, they're nicely marked. This is SB-610, but it's got 0.47 on that one. I can't read these. 0.1 on that one, etc. So, you know, it ought to be relatively easy to go through this. Put these capacitors in, and then we have the can capacitor. SB-610, it says. These are built to order, so there will be some, if you order one of these kits from Hayseed, you may have a delay because it takes them a while to build these. Now this thing is actually kind of heavy for what it is. I'd say it weighs easily as much as all those other capacitors combined, and I think they used kind of some heavy metal to make this shell. I don't think this is not a vintage shell. It's not like a restuff or something. It does seem to be like it's a separate piece there, so it's kind of stuck on. Maybe it's glued on. The bottom has been marked with a triangle, the kind of circle, the square that match the original capacitor. I don't know if these bases are made or where they come from, but I'm assuming what we've got in here is some traditional capacitors inside of this. They've been stuffed in here, they've been soldered to this, and then probably the whole thing has been glued together. I really can't pull it apart. I don't want to destroy it. It's a little bit shiny, reflective, but it's a nice heavy duty, it seems like a quality built can capacitor, and we'll use it to replace that old can that is in the SB-610. So again, this is why I really went with this kit to get this can capacitor that's going to look original, and it's probably cheaper than I could have gone about trying to make one of these myself. I don't even know where I would have got this metal tube from. I don't know if these things are it's just commodity tube that's been cut. Be interesting to talk to the guy who builds them and find out how he does them. But it looks really nice. I mean, it feels solid, sturdy. I've actually tested it with my tester. The caps are good. He says he uses good quality caps like Nichicon and similar in these. The ratings are written right on there. It's actually the legend of which terminal goes with what. That's pretty nice. That can capacitor is down inside of here. We will have to, we'll want to take some good pictures of him. Then we'll want to pull all of the wires off. One of the reasons why I bought the resistor kit was so that I can just throw away these resistors that are on that can capacitor. You know, why bother to save them? Okay, so before taking out the can cap, I did make a diagram of it. I marked front and back of the SB-610. I marked the colors of the wires, which terminals they hook to. There's a couple of resistors. I wrote down the color codes on them, the colors of the wires, the symbols on the can cap. So we're going to get that out of there. It's not going to be the easiest thing to get out. Now, some people will just cut the wires off because you don't melt all the insulation when you're trying to pull them loose. I'm going to try to desolder them and get the wires off without cutting them. The original resistors will just leave in there. And then we're going to have to get at least one of these terminals here has solder on it. So we're going to have to try to get that desoldered loose, and the thing will just drop out. Now you probably could, there's some screws holding a metal plate on, you could probably get it out and then pull the cap out this way, but you know, then we're going to have to get all this wiring out of there. So I'm unconvinced that I want to do that. It is tempting to remove the wiring because it'd make it a lot easier to work on. But on the other hand, I don't know that I want to replace all the wiring. We'll see. I may not film all of the disassembly steps just because I'm going to be in there with the soldering iron and blocking your view anyway. Okay, so I've got the original cap loose. I unhooked all the wires. The tabs I was able to twist straight, except for this one with the solder on it. I just twisted it back and forth until it broke. Now, whoever had tried to solder that before, their solder didn't stick to the metal at all. A cold solder joint on that ground on that cap, so that wasn't good. But anyway, we'll pull it out, and then I'm going to put this good one in its place. Okay, the new Hayseed Hamfest cap is installed right here. Rather than twisting these things sideways, I bent them back. I think that's going to be a little bit easier mounting method, and it'll get them out of the way. Rather than soldering the one that's buried in there in the horrible place, I think I'm going to try to solder this one right here. And I will actually, to solder it, I will use my desoldering iron because this thing is very high wattage. I'm just not going to engage it to suck the solder out. We'll just use it to heat that up and solder that in place and see if we can get it to stick to that metal. Okay, I got a pretty good solder joint right there. I soldered it in with a hackle. It looks like it's stuck pretty good. Next task is going to be to connect all these wires back up and install the two resistors. So I took the can cap over to my tester and checked it out, and it actually did not test bad. So maybe it was still good, but it probably wouldn't have been good for long, and you really don't know until you give them power for a while too. I'm still glad I replaced it. Next up, I'm going to replace these ones that actually did drip electrolyte all over the place. And Hayseed has given me these two replacements here. So we've got 0.1 microfarad 1600 volt, smaller capacitor, but it actually has a higher voltage rating than these black ones. And for this one here, giving us this one here, I believe is 0.15 microfarad at 2000 volts. So also about 400 volt higher rating than this cap. So that'll be good. I will pull the ones that we actually know are bad. And the other thing is I do have some spaghetti tubing. The kit did not come with this, but I keep some of this on hand for vintage projects. And you know, you can take it and you can often, if you have the right size, you can push it over a lead, and then your lead is kind of got some insulation on it. I kind of like doing it, especially when you replace big cap with a smaller cap with more exposed wire, more chance of sticking your finger in there sometime. I like the spaghetti tubing, so you can find it on eBay. It's good to have some on hand for this kind of thing. Okay, so I replaced all three of the vintage capacitors here with these new ones. Of course, this is the one here that was leaking all over the place. It's been replaced. I also replaced some of the resistors associated with it that came in the kit. So we pretty much got this whole section here taken care of. I think next I will turn my attention down here to these two large capacitors, which we have two a lot less large capacitors go into their place. Look like 47 UF 450 volt. These were 350 volts, so again, the new kit ups the rating, should be more durable, longer lasting caps. Okay, the two big caps are replaced with these newer caps here, as well as the resistors there, and here. I think there's still more caps to replace on the bottom. There's this, here, and this one. But I think I might switch over to the top and work on this funny looking one over here next. This one here that's kind of cracked on the end and there's wax all over the outside of it. That one seems suspect to me. So that's the one we'll do next. Okay, I pulled the weird waxy looking one out. And I put this nice new one in its place. I think it's also time, since I'm here, I'm going to put some deoxit on those switch contacts. And I tend to use the deoxit in the little jar. It's not recommended to use the spray deoxit. It can get into the wafers and swell them. It can get into the tube sockets and create like conductance problem when it dries out. So you take this and you can put it on there kind of sparingly. Now I'm tempted to just power it on and see how it works and see if we fixed it. Let's take a look. I know there are more caps on the bottom, but I don't think they're as critical as the power supply caps that we replaced. So we still got, you know, these two. They're just a little bit harder to get to some of these. And this guy, you know, they're not leaking. I don't know, maybe we'll see if we can replace those. Okay, I've replaced a whole bunch more of these capacitors. I replaced these two here, which I think are 0.2 microfarad. And I replaced this little guy up front. He was actually this big black one that was up front. And he is a 0.1. Then I got in here and I replaced these little electrolytics. There were these ones here that were down in there. Those were 10 microfarad lower voltage ones. It's interesting, the schematic showed a resistor on here, a 6.8K resistor in parallel with that capacitor that's not here. I don't know, maybe it's a different revision, maybe the builder forgot to install that. I'll have to look into that. Other than that, everything went fine, except I have two capacitors left. It's one of those situations where you have extra parts and you got to ask, what did you screw up? And I'm thinking possibly I've got these two guys, these big guys here. These are marked as 0.2. This is 0.2. I'm guessing it's to replace those two. I may not bother for now. Assume those ones won't go bad. We'll see. I'm getting anxious to power it on and take a look. I did find one other thing. It's kind of interesting over here. There's this 1600 volt 0.02, and what someone did when they assembled this, they bent this over, maybe when they put the case on, and they busted it off. So I'm going to see if I can flip it around, if it's not too fragile on that other side, solder it back together and get that thing back intact again. It's time to power this thing up and see what happens. So a few things that I'm looking for is nothing to catch on fire, no smoke to come out of anything, and a green line across the screen. Let's plug it in. It's good so far, but we do have the power off, so let me turn the power on. We have neon light, but as of yet, no, oh, there's a dot. Our focus. So up, down, or left, right. But our sweep isn't really working right. Horizontal gain. So I've got a theory as to what the problem could be. There's these two diodes, this one here and this one here. Now, I know people are going to look at that and say that doesn't look like a diode, but these are selenium rectifiers. This is what diodes look like before they look like diodes. So these are part of the voltage doubler, and what's supposed to come out at the end of this cap here should be 1600 volts, as long as these caps are good, the transformer's good, and those diodes are good. So let's I'll get my voltmeter that goes up that high. We'll attach to the output there. I do not know that my wire is rated 1600 volts, so we'll be kind of careful with it. And then let me go over here and we will look at the voltmeter. Now my Fluke that I would usually use, my nice digital meter, was only rated at 1000 volts. So we're going to try this out, and this is my old Volt Ohmist vacuum tube voltmeter. And it has a scale that will go up to 1.5 thousand volts. So 1500 volts. We should max that scale. The voltage is actually supposed to be negative, so we've got this on the DC minus scale, and we've got the range maxed, and if our voltage doubler is working right, this will go all the way to full scale. Now let me plug in the Heathkit, and what do we see? We see it only going to half scale. Now it could well be that this meter is out of calibration. I have not calibrated it, not in a very long time, but let's just assume that it's also possible, given that the SB-610 is not working right, that it is something wrong in that voltage doubler, and that something could very well be those two selenium rectifiers. Okay, so the odds of finding a replacement selenium rectifier in 2022 are probably pretty slim. Even if I did, why would you want to put a replacement selenium rectifier in? They don't have that great a longevity, and they've got to be pretty old by now. So I've made some replacements. And what this is 4 1N4007 diodes in series. I made one of them to replace this one, another one to go down here and replace that one. These are rated 1000 volts each. 2 of them would have probably made the voltage rating. 3 of them is good and safe. 4 of them ought to more closely approximate the voltage drop of the selenium rectifier, which was a little bit higher than the voltage drop of a silicon diode. So I'm going to go ahead and replace those 2 with these replacements, and then we'll see if we've got the thing working. Okay, right there you can see where I replaced the 2 selenium rectifiers with the strings of 1N4007 diodes. Now it's time to try it out. Okay, we've got the multimeter hooked back up. Let's plug in the oscilloscope. Oscilloscope's on. Look at that! Now we have full scale deflection. We have our 1600 volts on the voltage multiplier. I bet that was our problem. Now we've got much more intensity now, which is not surprising because we had half the voltage before. I'll flip it back over and we'll be able to take a look. Hook it up to the ham radio. And finally I did replace the last 2 capacitors, which were here and here. They were these shaped ones like this. This one was over here. They're a little bit of a pain, particularly this one, to get into it. But I figured why not use all the capacitors that came with the kit. And of course it wouldn't be right to conclude without showing off the new CAN capacitor that we installed. That is sitting right there between the transformer and the CRT tube. Okay, let's go ahead and try this out. I'm going to turn it on here. Turn it up to about half. There we go. It's lit up. We can adjust the focus. That's a good crisp line around there. Vertical, well, the gain doesn't do anything in this mode. It'll do things in the other modes. Vertical position, horizontal position, horizontal gain. This here is the sweep rate. About there is where I'm going to want it. Now I've got this hooked up to the antenna on the ham radio, so it will be monitoring as we transmit. So I'm going to get my mic out, my nice lollipop mic here, and start talking. Testing 1, 2, 3, 4. Testing 1, 2, 3, 4. You can also whistle into it like this. So anyway, what you're looking for here is just good, clean signals without any flat topping. So you'll see like a little burst when you first start talking, and then it kind of tapers off. So if we were to adjust the gain up too high, let me keep turning up the gain. Now you'll see it start getting fatter, and then it's kind of hard to see because it's going by pretty quick, but at this point I think it is pretty much flat topping and the ALC's kicking on. So I'm transmitting very loud right now. This would probably not sound good. So let me bring it back down to about there. That's about a good level, I think, around there. And anyway, that's what you would use a monitor scope for. Now if we adjust this, we can adjust the sweep rate back or forth. So you can see it's sweeping nice and slow now. We can adjust it up, and now it starts sweeping faster and faster and faster. But right around here, I think looks useful. So I think the scope is working pretty good. Now it does have a few more features. So let me try out the tone generator. I actually have a wire coming out here at the back. I will unhook my microphone, hook the tone generator up to the ham radio. I'm gonna turn the ham radio so it won't mute, so you'll be able to hear the tone. And that would be this dial here. So it should do a 1.5 kilohertz signal. I've got a little switch here that does the push to talk, so here it goes. So that is a 1.5 kilohertz. So we can, adjust the sweep back and forth. You can't really sweep it, small enough to see the sine wave, unfortunately. And that is the first tone. That's 1.5 kilohertz, and it's got this two-tone, which I think is 1.5 together with 1950. And there we can see the two-tone harmonic coming through there. Let's adjust the gain down, or just the gain. There we go. There, you can see that's a pretty nice signal. You don't see any flat topping. Now, one of the things useful with this is to monitor for flat topping. So let me adjust right there. I've adjusted my ham radio up too much, and now you can see we flat topped on there. And you can keep going. It just gets worse and worse and distorted. So yeah, you can kind of adjust your ham radio to where you're getting the best signal out of it. Okay, so let's wrap up. So I've turned on the ham radio here so you can watch me on the scope as I'm doing my wrap up. Why not? So the Hayseed Hamfest kit, I thought that turned out pretty good. I thought the value was good. The can capacitor was excellent construction, and it had all the other caps that I needed. Even had the additional pack of resistors that I ordered with it, and it was nice to be able to replace those resistors. The one thing I didn't have that didn't come with it was replacement diodes. But I did not expect there to be replacement diodes. So no surprise there, but that just does mean, you keep in mind, when you go to recap something, you may run into some other odds and ends you didn't think of, like a bad selenium rectifier. That kind of stuff happens. Anyway, I'm pretty happy. I'm happy enough that I did go ahead and order some Hayseed Hamfest kits for my transmitter, my T4XC, as well as my receiver, my R4C. I'm going to recap both of those. We'll put that nice can capacitors in them. The monitor scope itself, I think it's pretty cool. I've always, liked the iconic thing about being able to look at something and see my voice going across it. It's always kind of fun. You can find these SB-610s on eBay, like between 100 and 200 for one that probably works. Between 50 and 100 for one that's going to be like this one I got here, that's going to be a pile of rebuilding to get it to work right. There are other choices, so if you see this thing I have here from VK Amp, this is a little thing. They make these in Australia. This is a high quality RF tap, and you run your antenna through it, and then it's got to pick off there for your oscilloscope. So you could actually do this very same thing on any oscilloscope if you wanted to. Anyhow, I think that's a wrap, so I hope you enjoyed this video. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.